Let's welcome Santiago, who's going to tell us about Pooch.
Okay, thank you very much. Okay, so I'm Santiago Soler, and today I'm going to present you Pooch, a friend to fetch your data files. So a little bit about me. I'm a physicist and a PhD in geophysics from Argentina, and I'm working as a postdoc at UBC. And I develop and maintain two of the open source projects for geophysics, which are Fatiando Terra, that started in South America, and SciPy, that was it's being developed especially in Vancouver, but we have contributors from all around the world. And this is my first SciPy, and it's been awesome so far. So what is Pooch? Pooch is a Python library to download and cache data files from the web, while checking the integrity of those files, so we are sure that we are getting the right file we want. And we had the main goal while designing it to make it easy to use and to extend. So there are different use cases for Pooch. So if you're a researcher or a data scientist, you can use Pooch to easily download a file from the web through different protocols and services, and you can easily integrate that fetching of those files into your workflow to create a reproducible workflow. So every time you run this notebook, that script, or if you share those notebooks and scripts, everyone running them will ensure that have the right file you want. If you're a teacher or you are giving a tutorial and you want to provide your students or your audience with some files to play around, you can use Pooch, so you can focus on the things you want to teach and not so much on how to manually download that file, where it's located in your computer, etc. If you're a package maintainer, you can use Pooch to download sample data sets for your gallery examples and tutorials. So let's get into the shoes of one of these characters. Let's start with a researcher. So let's say you want to download some file. So I have this link to the SciPy website that has a file, like it's a data set, with the seafloor age in different locations of the world. So I can go here to this data, go here to the grids folder, and let's find this file. For example, the 6 minutes resolution one. Sorry, this one. So we can copy the link to this file, and let's go to our Jupyter, and let's import Pooch. And let's store this URL I just copied into a variable. And then I can use Pooch retrieve to get that file. So I can do pooch.retrieve and put the URL. And I don't know the checksum, like the hash of this file, so I'm going to put known hash equal to none for this case. And let's store the output of this function into an fname variable, and let's print it out next. So if I run this cell, Pooch is going to download the file. By default, it will download it to the cache folder of my OS. It will prompt me the hash of this file, and it will output me the path to that file. So if I want to use it, for example, this is a netcdf file, so I'm going to import xarray to open it. And open it with open data array, and pass the fname here, and let's store this output into a DA variable like this. So I can open this file just downloaded. So Pooch is computing the hash. So if I copy the hash here, I prompt it. I can copy it here, paste it here. Let's do this in the known hash. And if I run this cell, it's going to happen two things. So first, every time I run this cell, I will ensure that you will get the right file you want. But now, since I already downloaded the file and it's already cached, I'm not re-downloading it. So that saves time and bandwidth. Okay. So Pooch is capable of downloading files from different protocols. And it can also download files from services like Zenodo, Dataverse, and Fixture that allow us to create repositories with a DOI. So for example, I have this repository with land and ocean temperature records in Zenodo that I can just link it to the DOI of the repository. Hopefully internet works. Okay, it works. So here is the repository with the data files. And this repository contains a few data files. So let's say I want to download this txt file with the global average monthly temperature. And what I need to do is, instead of getting like the actual URL, which might change depending on how Zenodo is storing those files and the API, I can just go and copy the DOI of this repository. So I can go back to my notebook here, and I can put DOI equal and paste it here. So let's remove these things here. Okay. So I have the DOI, and then I can go back here and copy two things. I can copy the file name. Let's put it here in the variable fname. Oh, fname. And one other thing I want to copy here, I don't know if you can see it. Okay. It's the MD5 hash of that file. So Zenodo is already giving me this hash for this file. So I can just copy it and paste it here. So I can do checksum equal to this. So if I have this, I can define a new URL now that is going to be the DOI, and then the DOI number of that repository slash the file name I want to download. And then I can use Pooch retrieve. So fname equal Pooch retrieve and pass URL, and known hash now is going to be my checksum I just got from Zenodo. So this code will again download the file from Zenodo directly without needing the actual URL where that file is hosted. I just need the DOI for the repository, the file name, and the checksum I got from Zenodo. Okay, so what happens if you want to manage multiple files, right? So if you're using Pooch retrieve, you'll have to do multiple calls of this function. You'll have to keep track of the URL for each one of the files, the hashes of each one of the files. It could be a little bit cumbersome. So instead of using Pooch retrieve, we can actually use the Pooch class with a capital P. So let's go to this other notebook here, where I can import Pooch in this cell. And here I have a cell that defines a DOI for the same repository with the temperatures. But now instead of downloading one of those files, I can list two of these files. And I will create a registry dictionary. With the values of the dictionaries, they're going to be the file names, and the keys are going to be the file names, and the values are going to be the hashes. So once I define this registry, what I can do is define like a puppy, for example, with pooch.create. And I will need to pass the path where I want to download these files. So path. This can be any folder in your computer, or you can actually define a new folder in your cache. So you can do that with pooch.os cache here, and let's call it temperatures. Yeah. The other thing I need is the base URL. So in this case, since I'm downloading from Zenodo, the base URL is going to be the DOI. So it's going to be DOI, column, DOI. And no. Okay. And the third thing I need is to pass the registry. Okay. I can create this puppy, and then I can tell the puppy to fetch one of these files. So I can get, for example, the file name of the first one. I can copy that one, paste it, and it will download it. Okay, it's downloading. So what happens if I want multiple files? So I can just easily say like f's names. It's going to be a list of puppy fetch F for F in puppy registry, and I can easily get all the files in my registry. And if names is not defined, and this one, sorry. So if I run it again, actually, because I downloaded in the first run, I'm just caching it and getting from the disk. Okay. And so Pooch has more features than these ones I showed you. So for example, let's say you want to download a zip file or any archive file. So you can define processors, which are callables that you can pass to the retrieve function or to the Pooch object to carry out operations after the file has been downloaded, check the integrity, and cache in the folder. So for example, if you want to unpack a zip file, you can use one of the built-in processors we have, that's pooch.unzip, and by passing the processor, the retrieve function will return you the full list of the unpacked files. You can also define your own downloader. So let's say you want to download files from another protocol that is not currently supported by Pooch, or you want to download from a service with a given API. You can define your own downloader that is basically another callable. It could be a function, it could be a callable class, and you can define it, pass it to the retrieve function through the downloader argument, and you can download from anywhere you want using all the tools already in Pooch. So let's switch gear and let's get into the shoes of a package maintainer. So usually if you're developing your awesome open source library for science, you want to include some gallery examples and tutorials. And usually in those gallery examples and tutorials, you want to use some sample data sets, some real world data sets you want to use. And you also want your users to be able to run that code you have in the tutorial, and you expect that code to work as it is. So there are a couple of techniques you can do to allow your users to get hands on those data sets. So one of them could be packaging those data sets with the code, but that's not ideal because if you have a lot of files, your package now is growing too big. So that's not smart. But what you can do is to actually provide utilities for your users to fetch those data sets, those data files when needed. So for example, I have a repo here I created just for this. There's nothing too smart about this. So this is a ice sheets package I created, and where here I have some Python code that does some science stuff. And here I have a dataset folder where I included 2 CSV files. These 2 CSV files contain records of the ice mass balance for Antarctica and Greenland. So let's say I want the users of this package to be able to fetch these data sets when they want. So what I can do is go to my local repo here, where I have the Python code for my package, and I have this datasets.py file. So here I can import Pooch, and I can define a registry with the file names of those 2 files and their own hashes. And I can define another puppy here that is going to be Pooch create, where the path where all these files are going to be downloaded can be, again, a new folder in the cache of my OS. So I can do pooch.create, oscache here, and I can call it ice sheets, for example. And for the base URL, I need to find the common URL for these files. So if I go again to my repo, and I click here in the CSV file, GitHub is showing me the CSV file in this website, but this is not actually the URL for the CSV file. But if I change here, instead of blob, I put raw, I actually get the URL for the raw file hosted by GitHub. So I can go copy this URL, paste it here as the base URL. I will remove the actual file name because I only care about the base URL. And then finally, I can pass the registry. Right? I can save this file. And now my users could import Puppy and just download any of these files. But in order to do so, they will need to know which file are stored in the registry, and that could be a little bit cumbersome. So I can actually define functions so they can use to download these files. So I can use, for example, def fetch Antarctica. And I can do fname equal puppy fetch Antarctica.csv, and then I can return the fname. Or I can get more creative and make the life of my users easier by saying like, okay, let's import pandas as well, and let's load this CSV. Read CSV. Oh, sorry. The fname, and I can return the data frame I want. And I can do something very similar with Antarctica, Greenland. Okay. So if my users import a package, import site sheets, they can access these module data sets, and they can call the fetch Antarctica function. And they will get the data frame. Pooch will download the file, open it with pandas, and return it. But we have a problem here. So all these two functions, what they are doing is downloading the file, these two files that I'm hosting on my repo under the main branch. So if I update these files, I don't know, maybe there are new data coming and I want to add that new data to those files, any previous code I release will stop working because now the expected files that are in main are not the ones that are expected in their own registry. So instead of telling these functions to download from main, I can actually say, okay, download it from a given version, which I can specify here, version like 0.2, for example, and that will work, right? If I'm on 0.2, this will always download the 0.2 versions of these files. But I don't want to keep updating this function every time I have to do a release. So what I actually can do is import the version number here. And for the version here, I can actually put v and some version. And then I will say like, okay, if the version is a development version, I don't want it to download from 0.2. I actually want it to download from main. So I can put version dev equal main. And that's it. Every time I make a release, it will download from the actual version you're running. And if you're running a development version, it will download the files from main. Okay, let me talk to you a little bit about Pooch. So Pooch is part of the Fatiando Terra project, which is a project for developing open source Python tools for geophysics. It started in Brazil over 12 years ago. And Pooch particularly was born in a SciPy sprint in 2018, where Leo was working in collaboration with the guys in MedPy, especially with Ryan May and John Lehman. And they noticed that these two projects had very, very similar code for downloading these data files for their own gallery examples. And they decided to create a single package to make lives easier for everyone. So that's how it was born. And throughout the years, it became quite popular that right now there are a lot of projects using it, such as scikit-learn, Apari, Xarray, MedPy, scikit-image, YT. And according to GitHub, there are more than 300 projects using it. And so, yeah, it's been great to see how Pooch was adopted by the community. And let me talk you a little bit about the future roadmap we have for Pooch. So we are starting to think about the roadmap for Pooch 2.0, and there are a few things that we'd like to see there. So right now, instead of defining the registry as a dictionary in your Python file, you can actually define it as a TXT file. And we'd like to move from that TXT file that created quite a lot of issues to a standard file format, such as like JSON files, for example. The other thing we would like to improve is right now, if your files have custom URLs, you can actually define a dictionary with the file names and the custom URLs for each one of the files. And then you'll have to define another registry, which is another dictionary, with the file names and the hashes. So having two registries is kind of awkward, so we would like to include, to have only one that merges the two, the URLs and the hashes. We would also like to improve the logging, so to make it more configurable and flexible. So if a package maintainer doesn't want their users to get a lot of logging from Pooch, to make it easier to turn that off and on, or even plug their own logging if you want. And finally, there are a lot of people in the community asking for particular downloaders for very specific services. And we've been hesitant to include or start developing those and maintaining Pooch, mainly because APIs change and it's hard to make a release every time an API changes just to support it. So instead of merging those custom downloaders into upstream Pooch, we're thinking to develop a plugin system so the community can develop their own downloaders and share it so you can easily extend it. So if you're interested in Pooch, you would like to use it, check Pooch docs at fatiando.org/Pooch. And before I go, I would like to thank all Pooch contributors that without them, this project could not exist. And thank you all for your attention.
Thank you, Santiago. I'll start with the Slack questions this time. So does the Pooch mascot have a name? That's Josh's question.
It doesn't. Actually, that's kind of a pun because we tend to use in the documentation different dog names. I think there is Audi somewhere. So I think that's kind of like a wild card for pick your favorite.
Great. And then Alex asked, does Pooch expose any functionality to retry requests or pick up for incomplete files on wonky web servers and data sources?
So if your file is downloaded and it's corrupted in the sense like it's not complete, it will actually throw an error because the hash of that file wouldn't match the hash you pass to the retrieve or to the fetch in the registry, sorry.
Okay, then Darren asked, does Pooch have a cache eviction policy so that old files you have not referenced for a long time get deleted to save local disk space? If you eventually want them again, they would just be re-downloaded again.
Can you repeat the question?
Cache eviction. So if you've downloaded a file but you haven't referenced it, you haven't tried to re-Pooch fetch it for a long time, will it get automatically deleted? Or
no, we don't delete the cache. I think there are discussions on that. I personally feel very scary of running RM3 on another person's machine. So yeah.
So you first, then you.
Yeah, thank you. This was really interesting. My question is related to the previous question on Slack. So did you think about maybe to implementing something downloaded by chunks, and if it's not complete, then just retry? Because this is what we do with the pure Python, but I think this is really useful. And I have one more question, if it's okay. How about multi-threading? Will it work, in parallel?
So for the first question, we are actually downloading in chunks. We don't want to download the whole content and load it in RAM. So we are actually chunking the content of the response. For multi-threading, I haven't tried it, but I think if you can use multiprocessing, define a pool and call multiple retrieve functions, I think it should work.
Two questions, one very simple, one maybe a little more complicated. What's the biggest size of like on-disk cache that you know of Pooch managing? Like, are we talking about like 50 megabytes of data in total, or is like someone using this to handle caching for 100 terabytes?
I don't know. I actually had a talk with Nathan yesterday, and you were saying something about downloading huge files in YT. Okay, so you're downloading gigabyte scale data. Okay.
And then my second question is, have you experimented with, or is there support for shared caches amongst groups of users? The use case I'm thinking of is on an HPC server, you may have like 50 users who are part of the same group who all need access to the same like shared data that comes from an external web service. And you could have them all of those live in one directory rather than them like, having 50 copies of everything.
So with Pooch itself, you can define the output, like the path where you want to download all those files wherever you want. So yeah, you can totally define one common cache folder for every user and dump it there. Now, if you're thinking about like, okay, you have like some other person has another package that uses Pooch. They have their own Pooch class defined. Yeah, I don't think it would be easy to like change that Pooch class.
Like locking, saying like, hey, I'm currently downloading file A. You shouldn't start downloading it. That doesn't exist.
No, we don't have logging, although there is an issue that's quite recent that some user asked about logging, and we provided like a solution without having to write anything on Pooch. So yeah, I can share it then later in the Slack channel.
Yeah, so question also was on shared, which is fine, but realistically you will find the problems with the permissions, locking and all that stuff. So in ideal case, it would be having something internal rather than the external to Pooch itself. But then my second question on, is there any support for simply folders? I mean, obviously the good way is to put folder into our Hive, but it's not necessary in all case. And I would say I do not care about particular file names, structures underneath, but just would like to go with the entire folder and do not manage the hashes, just to leave it to Pooch so it would check all caches, will remember them, and will store them in the cache, and will just ensuring that things get consistent, anything like that.
I don't think I understand the question entirely, but
In case I would like to download an entire folder,
yeah,
like 100 files.
Yeah.
I obviously don't want to manage all the hashes and file names, and in general, I do not care like how it would be supported currently, if it can be.
Yeah, I have to check, but I think if you define nuns as the values for the hashes in the registry, it will ignore them and it won't check the integrity of those files. Or you can just use like retrieve and pass the known hash as none.
I think if I understood the question is that can you not care about the cache on the initial load and then start caring about it? Is that right? And then to make sure that it stays the same after that initial download. We stumped him.
Yeah. Can we discuss it later? Yeah. I don't think I understand totally the question, but.
Anyone else in person? All right, let's thank Santiago.
Thank you.